and our Embarcadero counterparts are not hearing us right now. Craig, JT, Sabrina? Oh, okay, there you are now. Perfect. Okay. Sabrina, JT, over to you.
Yep. Excellent. Well, thank you. Welcome, everyone. Thank you for joining us today for our presentation on FireMonkey, the next generation business application platform. FireMonkey is new as part of the XE2 release, and we're really excited to show you FireMonkey today. So for the next half hour, we're going to talk about FireMonkey, followed by a demonstration so that you can see FireMonkey in action, and a Q&A session at the end. Also, Kevin from TechExtend is going to be doing a drawing for an iPad 2 at the end of this webinar. So to be eligible to win, you have to be present for the duration of this webinar. During this presentation, you will also see how FireMonkey lets you quickly build visually engaging and data-rich HD and 3D business applications with blazing native performance on Windows, Mac, and iOS. I'm Serena DuPont, Product Marketing Manager at Embarcadero Technologies, and I'm joined today by John Thomas, Director of Product Management. So let's get started. So we're really happy to share with you today how Embarcadero is reinventing application development with the introduction of FireMonkey. So to give you an overview on what FireMonkey is, so as part of the XE2 release, we have introduced FireMonkey, the next generation business application platform. Now, FireMonkey provides multi-platform application development, which means that you can write an application once in your Windows IDE and then compile it for and target both Windows and Mac. So that is a huge time saver and also allows you to very quickly create an app on Windows and then deploy it for Mac. And with FireMonkey, you can also build native iOS applications as well. Also new in FireMonkey, we have styles that you can apply to user interfaces, so you can create really modern themed user interfaces. And we're also able to apply real-time image and animation effects to your UIs and different components that you're adding to your applications. So this is a really neat feature that's with FireMonkey. You can create very nice visual-looking user interfaces based on vector graphics, so they're scalable for all the different devices. For rendering graphics, FireMonkey uses Direct 2D and Direct 3D for rendering HD and 3D graphics and user interfaces on Windows. And on the Mac, we're using Quartz for HD application rendering and OpenGL for 3D rendering. Also, applications are native Delphi and C++ and are built 100% on the Object Pascal framework. So to talk about FireMonkey a bit more and what it means that it is native and what native CPU and GPU powered application platform really means to you and your application development. You can very quickly and easily compile natively to Windows, Mac, and iOS. So you would get started with either an HD or 3D application, and you would build it on in your Windows IDE, and then you can run it on Windows, or you could target Mac. And you can also create native iOS applications that you could then package up for distribution on the Apple App Store, for example. The application itself, implemented databases and animations are CPU powered, and the user interface, graphics, and effects in FireMonkey applications are GPU powered. So there are two different types of FireMonkey applications that you can create. One is an HD application or HD forms, and the other one is a 3D application. So the HD application lets you create scalable vector user interfaces that are powered by the GPU. And what that means is that you get maximum resolution on any device. So no matter what type of device your customers are using, whether they're using a Windows computer, a Mac, or an iPad, for example, you get maximum resolution on those devices, and the UIs look crisp and really nice. You also get hundreds of visual UI components. So again, you can access all the we have different drag and drop components. If you're familiar with Delphi or C++ Builder, different drag and drop components, several hundred that you can choose from out of the gate. And the style engine is also GPU powered. So if you look at the graphics that we have on this slide here, the graphic on the far right is showing you one of the styles, the dark style that you can apply. And we'll get into some more depth on some of the further slides, but that's just one example of a style that you can apply to either one component or your entire user interfaces. And you can also create user interfaces with transparencies and transition effects as well. Now, 3D applications. Now, FireMonkey also lets you create 3D applications, and the 3D forms are also powered by the GPU. Now, we also leverage hardware-based lighting, textures, and animations. So nowadays, you see all these great graphics on multiple devices, and now with the introduction of FireMonkey, you can build for multiple platforms, and you can leverage all the graphics capabilities and render these graphics with the power of the GPU, which means very fast native performance for you and your customers. And 3D forms can also contain high definition or large high-resolution vector-based UI elements and effects. So you could, for example, create an application for the iPad that is a three-dimensional object, and we support out of the box several 3D formats that you could then load in. You could have, for example, rotate a car around, and then you could have HD buttons, and you could style the application to your customer's needs. So talking about effects and animation. So we ship with over 50 plus Photoshop-like GPU-powered effects. So on the first graphic here, you see some of the effects that you can apply. And if you're familiar with Photoshop or other graphics programs, you'll be familiar with some of these effects. They're, for example, black and white effects, blur effects, reflection effects. These are all effects that you can apply to images that you could render out images with, or you could also apply to user interface controls. So for example, you could have a glow effect that is triggered by somebody rolling their cursor over a button or a field. You can also have some simultaneous multiple effects without a performance hit. So you're really able to build very powerful user interfaces that are very feature-rich and also data-rich for your customer base. And we also offer path-based animation for all HD and 3D user interface and graphics as well. Now, also new in FireMonkey is LiveBindings data visualization. And this is a feature that's new in both FireMonkey applications and also VCL. And what LiveBindings means is that it lets you connect any user interface, HD or 3D graphic, to any data source, and allows you to create interdependent bindings. So what does this mean? So for example, if you look at the graphic here on the slide, you can see that some of these countries are protruding out of this image. So for example, you could link an edit field with data to a column or an interactive 3D graphic, and it could grow over time to display population, for example. So the different columns could take on, the height values could be related to the data in your edit field. So it really allows you to visualize data in new and exciting ways. And of course, rapid development. FireMonkey has this full suite of visual user interface components that I mentioned previously. We have different buttons and different user interface components that you're probably already familiar with Delphi and C++ Builder. Very powerful, drag and drop, fully customizable. You can resize, you can add powerful styles to it. We ship with a list of included styles that you can apply, including native styles, so you have Windows 7 styles, iOS styles, Mac styles, to give your users that custom look and feel that they're expecting from the applications that they're building, and that the user experience that they want to be able to provide to their customers. And you can also download additional custom controls from the community and third-party component developers as well. So how is FireMonkey different compared to other application platforms in the marketplace? So we have 4 different ones that we are going to compare FireMonkey to, and kind of give you a quick overview of how FireMonkey is different. So when we're comparing FireMonkey to managed solutions such as Java and .NET that run on software-based virtual machines, those don't directly tap the performance of features of the CPU and GPU in your hardware, unlike FireMonkey that is able to fully leverage the power and speed of your CPU and GPU. Now, compared to RA web-based platforms such as Flash and Silverlight, those are powered by interpreted scripts, and they run in software-based virtual machines, and those also don't have the speed of native applications. And in addition, those typically also don't have much access to system services as well. Now, compared to HTML5 and CSS3 frameworks, those are limited in capabilities, footprint, and performance. And when we're looking at game engines, such as 3D and 2D graphics frameworks, those are really aimed at gaming, and they lack standard user interface and also database and services connectivity required for building non-gaming applications. So while all these technologies have their benefits, FireMonkey brings the best of them in the form of a native application platform. And FireMonkey lets you unleash the power of the CPU and GPU hardware with high-performance native applications and applications delivering the most visually rich GUIs as well as flexible database and services connectivity. So here we have kind of a quick overview of VCL and FireMonkey. So if you're creating a VCL application, that would be for Windows only. If you want to target multiple platforms such as Windows, Mac, and iOS, you would choose FireMonkey. So FireMonkey Technology, we touched on this briefly, but if we're talking about how are these graphics rendered and what are they using in regards to leveraging the speed of the GPU and CPU. So to render graphics and user interfaces on the Mac, if we're rendering HD graphics, we're using Quartz for rendering those. And for rendering 3D graphics on Mac, we're using OpenGL. Now on Windows, we're using Direct2D for HD graphic rendering, and for rendering 3D graphics, we're using Direct3D. Now in the case when Direct2D is not available, FireMonkey uses GDI Plus for HD vector forms and controls rendering. So a FireMonkey architecture. So a FireMonkey object is derived from a base T component class that gives FireMonkey objects their basic behavior. So you can create FireMonkey objects, destroy, and release them. Now the T component is a base class for all components, and it's the common ancestor of all component classes. So what does that mean? Any FireMonkey object can contain other components, which makes it versatile and very easy to create customized FireMonkey objects. You can just drop one FireMonkey component onto another, and it will become a child of that component. So FireMonkey is heavily dependent upon interfaces. Now FireMonkey has several interfaces, such as the control interface, which lets you handle focus, mouse, and keyboard events, and is implemented by T-Control and T-Control 3D. Now, in addition, FireMonkey also has other interfaces such as Root, Scene, and Viewport 3D, and we will discuss here some of the functions that those handle as well. So the Root interface handles focused, captured, and active controls, and iRoot is an interface to top-level containers and is implemented by T-Custom Conform. Now, iScene is the container for HD objects and is implemented by T-Form and T-Custom Layer 3D. iViewport 3D is the container for 3D objects and requires a GPU and is implemented by T-Form 3D and T-Viewport 3D. And so we were talking previously about the 3D forms. Viewport 3D is a component, and that is something that you use in order to be able to bring 3D objects into your FireMonkey applications. So FireMonkey HD, 3D, and GPU. So FireMonkey takes advantage of the GPU whenever possible, and HD forms can be rendered on a computer without a GPU with a few restrictions. And in those cases, we would not have the T-Viewport 3D or shader-based filters. However, most computers within the last 10 years ship with a really powerful GPU that your customers should be able to leverage. Now, a 3D form also requires a GPU to perform sophisticated transitions and manipulations of the user interface as well. Now, the FireMonkey architecture. So let's talk about styles. So styles are something that has makes FireMonkey really powerful in that you can apply a custom style to your entire application or to just a specific component. So if we look here at the image that I have on the slide, we have a native Mac OS X style, and we have a Windows 7 style. And what you're able to do is you're able to drag and drop components onto your form, and then you can choose to select a custom style for a component, which you can customize yourself. So let's say you have a button and you want to change it to a red and black gradient, for example. You would just right-click the button, and you would choose a custom style, and then you were given various options per component that you're able to customize. And you can also save those styles out for future use, so you could create a style for multiple components that you're then able to apply to different applications. And that is also something that you can build in for your customers as well, so they can adjust the style of their application. So you can create theme-like, different themes that your customers could choose from to get a more custom user experience. And we also I also mentioned previously that we're shipping with several style files that you can use and leverage for Windows 7, Mac, OS 10 and iOS, and additional custom themes as well. And again, you can create your own themes for each particular button or component and control, or you could go and apply it to the entire application, and that would be done via a style book. Now, 3D programming. Now, one object model can be used to target multiple platforms. So you can bring in a viewport 3D and a 3D model. So for example, you have an OBJ file, this is a standard 3D object file of a car or a house that you want to rotate. Very easily, you can just put in a couple lines of code to achieve that, and then you could use that same component to target multiple platforms for Windows, Mac, and iOS. So FireMonkey also uses right-handed orientation in 3D, and for hardware acceleration, on Windows we're using DirectX, on Mac OS we're leveraging OpenGL, and on iOS we're leveraging OpenGL ES. So for FireMonkey animation. Now, animation allows you to add some really nice custom effects to your FireMonkey applications, and it's a very powerful feature. And the animations are used to change values of properties of different components over time. So animations are components themselves, so you can change their properties at design time as well. So for example, you can set up loops, and they can also be reversed. FireMonkey animations are machine speed independent, and they can be triggered by mouse over, focus, visibility, etc. So for example, you could set up a button and have that trigger some kind of effect, such as, you know, an image could move or data could populate on mouse over, and then the visibility could change, and it could change to a gradient, for example, or a color style via the click of a button of your mouse. So those are all things that you can set up in the object inspector under the properties as well. FireMonkey effects and filters. So FireMonkey effects and filters can be applied to both bitmaps and controls. So for example, you were to build an application that would let people bring in their own photographs and apply a couple filters to them and then render them out as graphics with those filters. You can go and do that by just adding a couple different filter effects onto your form. Very easy to do. And the same filters could also be applied to controls. So you could apply reflection filters, blur filters, etc., all to your controls to create really nice, stunning user interfaces and applications. And those could also be triggered by different events such as mouse overs, visibility, etc. And we also offer GPU-powered shader-based implementation as well. FireMonkey and Multi-Platform. So FireMonkey is a complete application stack and provides access to a runtime library, graphical user interface controls, database connectivity, and native operating system services such as file system services. So the IDE runs on Windows and will deploy your app to the target platform. So you can run the application on the target platform or then attach it to a remote debugger as well. Now, with FireMonkey, you can also create native iOS applications. So you'd use the RAD Studio XE2 IDE for that. And in this case, you would use Delphi to create native iOS applications. And you would create a new FireMonkey, either HD or 3D iOS application. And then you compile it for iOS. And then you can either run it in a simulator, or you can actually go out and run it on your iPhone, iPad, and iPod Touch, and then package it up for distribution in the app stores. So you're able to create really rich applications that are able to leverage database connectivity, access your data in iOS as well, and those are rich native iOS applications. So again, here's just a kind of a basic graphic that shows you would either select 3D iOS or HD iOS applications when you create your original application. Then you would select export to Xcode out of the RAD Studio IDE, and then you're able to open up your Xcode project on your Mac in Xcode, and you can either run it in the simulator or deploy it to your phone. Another new technology that we've introduced in XE2 is LiveBindings. And LiveBindings is something that you can leverage in FireMonkey as well. And LiveBindings lets you visualize data in new and exciting ways. So if you look at this graphic again, I mentioned this graphic earlier. LiveBindings is something that's supported by both FireMonkey and VCL, And what you can do is you can tie data to objects. So you could have data could be tied to any user interface or graphics object. So for example, you could have a data field that adjusts the height of a 3D object, such as what you see here in this globe graphic. So you create really nice new interactive applications that let you users interact more with the application and data than they've been able to before. And this can be done both programmatically or visually. And LiveBinding is also based on relational expressions called bindings expressions. So basically you can set up any kind of value to any object or component, and those can be triggering different data and effects using LiveBindings. So again, LiveBindings lets developers create a LiveBinding in runtime between components and objects at design time. So that really is a very powerful new feature that we've also introduced in XE2 that you're able to use in FireMonkey as well. So now we're going to get to the FireMonkey demos, and I'm sure you're excited to see FireMonkey in action. So what we'll do is we will pass the mic here over to John Thomas, or JT, and he will show you FireMonkey in action.
Thank you, Serena. So with this demo today, we're going to show you a couple of things. First, we'll show you how easy it is to create a FireMonkey application, to build and deploy it to Windows, and then how easy it is to build and deploy to Mac OS X. We'll show you a couple other demos of FireMonkey controls, LiveBindings, and then finally we'll show you a demonstration of building an iOS application with FireMonkey. So to create a new application for FireMonkey, we start a new project. You can use either Delphi or C++ Builder for these applications. And I can select either a 3D application or an HD application. For this demonstration, I'm going to build a FireMonkey HD application using the Delphi language. This is the typical design surface of a FireMonkey HD application. It presents the form, and I can start adding controls to the form. First thing I'll do is I'll add a button. I'll also add an edit control, so I can take input. And finally, I'll add a memo control so that I can show that input. So now we'll go into the source code of the button on click event. And what I'm going to do is I'm going to take the text out of the edit control and put it into my memo. So I'll call the memo access its lines and call its add function, passing it the text that is placed in my edit control. Okay, let's go back to the design surface. We'll make our screen a little smaller. And at this point, we're ready to build and test our application. Before I do that, though, let me show you the Object Inspector. If I select a component, I have the ability to modify properties of the component at design time. So as you see now, it says button 1 in the text. So what I'm going to do is I'm going to go to the text property, and I'm going to put add text. As I hit enter, you see it updated in the designer, and this will be what the control shows at runtime. So let's go ahead and run this application. You see my target platform is 32-bit Windows right now. I see. I picked the wrong memo. Let's try that again. Okay, so memo 2, lines add. So very simple to construct user interfaces, set up events, and actions associated with standard user interface input. So Serena had talked a little bit about some of the other features of FireMonkey that are interesting. One of those is being able to add effects very easily to a component. Let me show you one example of that. I'm going to grab a glow effect, and I'm going to apply this to my button. And I'm going to ask it to trigger whenever there's a mouse over event on that button. Okay, so we see the glow effect. We can change the color of the glow effect. Okay, so now let's go ahead and target 64-bit Mac OS X. So the way that I do that is I'm going to set up a new target platform. And I'm going to tell it that I want to deploy to OS X. Let's look at the host profile. Basically, I add a URL for my deployment machine. In this case, I'm running Windows hosted inside of Mac OS X OS. So this is the VMware address of my Mac OS X host. I also need to run a server on the target platform called PA Server. So PA Server is up and running, and now I'm going to be able to communicate to my Mac OS X target. So the IDE takes care of cross-compiling, deploying, and starting up my application on that target. And you can see now that I have an OS X application. You can tell by the buttons that have changed on the control. So that was a quick look at how to create your first FireMonkey application. It's very simple to generate user interfaces, the interaction with your application logic, and then to target other target platforms just by recompiling for that target platform. Let me show you a couple of the controls that are provided by FireMonkey. Serena mentioned we're providing hundreds of user interface controls. So this is the design surface showing several hundred user interface controls provided by FireMonkey. So let's go ahead and run this application. Okay, so you see a couple of the new controls here. You can also see some of the effects in action. So, for instance, I can change the opacity of a control, and I can rotate the control. You can also see how easy it is to integrate 3D into your application. Notice this is a semi-transparent window at this point, with a 2D control on top of it. So we also talked about styles. So styles can be easily added to your application dynamically. And in this case, I want to change to a Mac style because I'm going to build it and deploy it for the Macintosh. So these are some of the style files that we provide. Let me just show you a few examples real quick. This one is called Awkward Graphite. This one is called Ruby Graphite. We also have a Windows 7 style. And a Mac OS X style. So this is the one that I'm going to deploy now to my Mac OS X. Again, just as simple as creating a target, activating that target, and rebuilding it for it. So at this point, I'd like to also show you a example project for LiveBindings. So this is a pretty simple demo. Basically, the idea is to show you how you can connect any two data sets to one another. In this particular example, we're using a client data set to pull information out of a database. We're then creating bindings to the other controls within this user interface. Some of the user interfaces we're interacting with are a navigator bar, and this is not a data-aware navigator bar at this point. We have a glyph that we're going to manipulate, as well as a couple text controls, and a 3D image. Before we jump into the bindings, let me show you how it looks when I run it. Okay, I need to highlight this project here. And we'll run it. Okay, so as I navigate through the data set, you'll see a couple things happening. The text controls are updated with the latest information out of the data set. The glyph is growing, and the 3D object is being manipulated as well. In this case, it's being rotated and growing as well. Let's take a look at how we did that with LiveBindings. To create a live binding, you use this editor, and what we do is we bind a source to a control. So let me give you an example. The rectangle, for instance, is bound. The height of the rectangle is bound to our expression, which is employee number, out of our database. And we just cast it as a float, and it updates that top or that height value of the database. So as I iterate through and that employee number changes, you see the height change as well. Let me show you another example. For that 3D rectangle, we're modifying the height coming from employee number, and we're also modifying the Y values to rotate, the rotation angle Y value to rotate the object as well. And you can see that we can actually write expressions in here as well. We're casting as a float, and we're multiplying it by the value of 20. So let's talk a little bit about shaders and effects. So the effects, again, use the GPU. And what we're going to do here is we're going to run a bunch of effects in real time against this image here. So let me go ahead and run this one. Okay, so we have our image, and at this point we can start adding effects to it. This is being run in the GPU on the image. The image itself doesn't get modified at all, so you can always recover and reuse that image. But as you can see, the effects are very fast and running on the GPU. So I can stack effects, any number of them together, to get very interesting displays. This doesn't have to be just for images either. These effects can be run on controls and on any user interface component, anything that derives from T component, basically. So you can tell that this is real time as I'm moving around the magnify, for instance. So this is not being generated and then shown. This is actually running in real time against the GPU. And we're getting this excellent performance because we're able to do this on the GPU. Now let's show you a 3D application. So I'm just going to go ahead and build it and run it first, and then we'll talk about what we're doing. Okay, so this is just a simple application that takes two spheres and translates them around a cube. So we're going to just start doing things, for instance, rotating those spheres. And we'll also start rotating the box as well. So you can see this is all running in 3D, several hundred frames per second. You may see a little lag because of the WebEx presentation layer. Now what I'm going to do is I'm going to take this and quickly move this over to the Mac OS X by just setting up my new target. This is all shared source code. Just to quickly look at the source code and the designer, what you see here is a couple of objects set up. You can also see some lights that are set up. And these properties can be modified in the object inspector. So you can, for instance, change it from a spotlight to a point light very easily. You can change the color of it, the depth, all the common things that you would associate with managing an object that's supposed to cast light. So we're going to go ahead and build this now for Mac OS. And again, you'll see that there are no if-steps in here for between Windows and Mac. This is the exact same code that's going to run on both platforms. Okay, so now I'm running in Mac OS. Let's go full screen in Mac and add our animations again. So you should be able to see that it's very easy to create full 2D and 3D applications using FireMonkey that run on multiple platforms. Together with styles, you have new ways to present data to your customers and address their particular requirements. The final demonstration I'm going to show you is building an application for iOS. So this is a multi-platform application that runs on Windows and Mac and will also run on iOS. Let me just run this on Windows real quick. And we're using the iPad form factor here, but this is a Windows application that shows a couple of animations. These animations are very easy to set up in FireMonkey by setting up your spline and setting up your timeline. Now to move this to iOS, I create a new iOS application and then I export this to Xcode. It runs through an application that builds an Xcode format project file and copies over my path files as well. So let's switch over to Xcode on the Mac. And you'll see that I actually have the same source code over here in Xcode for this application. I'm going to tell it that I want to build and deploy for the iPad 4.3 simulator. And we're going to go ahead and launch it. So in closing, I think what I hope you saw today was that FireMonkey is a very powerful new application framework. It provides new ways to visualize data. It provides opportunities to build multi-platform applications, including iOS, and to leverage your code across all these operating systems, and also provides new ways to build styles around your applications and bind data to those controls. So at this point, I'd like to pass control back to Serena. And we're very close to a question and answer session.
Great. Well, thank you very much, JT. And I just want to mention that FireMonkey is available in Delphi XE2, C++ Builder XE2, and RAD Studio. And you can purchase it directly from TechExtend. The differences between FireMonkey and Delphi XE2 and C++ Builder XE2 is that with Delphi you can build Windows, Mac, and iOS applications, whereas with C++ Builder you build Windows and Mac applications. And just to summarize and add to what JT was saying, again, FireMonkey is the next generation business application platform. I hope that today you were able to see some of the capabilities of what you can do with FireMonkey, how it lets you fully harness the powerful GPU graphics hardware. You can build really visually spectacular applications and just invest in one platform and are able to deploy to numerous operating systems. Also, their applications are Delphi and C++ compiled native executables, which makes, takes advantage of the speed that lets you create very fast, high-performing applications, and also lets you leverage fully programmable animation and effects. So as like JT was showing you, you can apply custom effects to controls, user interface elements, etc. So your imagination is really the only limit when you're creating FireMonkey applications. So we hope you enjoyed this presentation, and we'll get